In this video, we will be covering concepts from programming that you absolutely must know in order to program in Unreal Engine. These are C++ basics that, if you don't understand already, I recommend you take my first course, which is a C++ class for Unreal Engine developers. If you do understand some of these concepts, feel free to skip ahead, but I encourage you to refresh on everything so that you have it all in your mind when you begin programming in Unreal Engine. The majority of these ideas involve classes and inheritance. These are the main ideas of object-oriented programming, and what gives object-oriented programming its strength. Imagine you have a class. And a class contains its own variables and also its own functions. And this class can be a parent to some child class, which derives from that parent class. So each child class will inherit variables and functions from the parent class, as well as have its own child variables and child functions. Now, a child class will have a function that was created in the parent class, and it actually has the capability of overriding those functions and creating its own unique version of those functions. Now, a child, being a parent itself and deriving from that parent, actually has access to the parent version of those functions. Even though the child will be overriding some of them, it still has access to the parent version. Now, a parent class may have a child class, which in turn may have its own child class. And this can go on indefinitely. And as long as you have a parent class with a child which has another child and so on, you have what's known as an inheritance hierarchy or an inheritance chain. A child class can have many children. In fact, there can be multiple child classes that derive from the same parent, and this happens all the time. So the inheritance hierarchy can get quite complex very quickly. A child class can also inherit from multiple parents, and this is known as multiple inheritance. So each parent in this case will have its own unique variables and functions, and the child class will inherit variables and functions from both parents. Now, when you have a given inheritance hierarchy, you may create a variable of type pointer to parent. So this variable is a pointer that can point to the parent class. But as you may know, a variable of type pointer to parent can also point to a child class. In fact, it can point to any child class in the inheritance hierarchy as long as it's a variable of a parent type. A parent class may have a function, and thanks to inheritance, each child lower in the hierarchy will inherit that same function. Now, as mentioned before, each child class can override that function and have its own unique version of that function. Now, if you have a variable of type pointer to parent and it's pointing to one of the child classes, when you call that function that was inherited from the parent class, the question may arise, which version will be called? Because the variable is of type pointer to parent, but the actual object that it points to is a child class. The answer is you always get the child function version whenever you call a function in this manner. And this phenomenon is known as polymorphism. When a variable of type pointer to parent is pointing to a child class, it points to an object that is also a parent itself. In fact, in this inheritance hierarchy, a child 3 object is also a child 2 object and a child 1 object. And there may be things that you might need to do as a child 1. For example, there may be some function that accepts a child 1 parameter, and if you have a variable that points to a child 3 object, you know your child 3 is a child 1 as well, but how do you pass a child 3 object without an error? In this case, what you can do is create a new variable of type pointer to child 1, and you can take advantage of a very special type of function known as a cast. A cast will take the variable pointer to parent, access the object that it points to, and convert it into a type child1 object. If this cast is successful, the cast function will return a child1 object, which you can then use to initialize your variable of type child1. Now that you have a variable of type child1 that points to a child1 object, you can then pass it to that function, and you won't have any errors because the function is receiving the parameter type that it was designed to receive. In Unreal Engine, there is a class hierarchy that you must become familiar with. Near the top of the hierarchy is a type of class known as an object. Derived from an object is the actor. Further down the hierarchy, the pawn derives from actor, and from pawn, the character is the child. An object is a very basic type of class. It can store data, but it does not have the capability of being placed in a level. If you want your class to be capable of being placed in the level, it has to be derived from at least an actor or lower in the inheritance hierarchy. An actor can have a visual representation, such as a 3D mesh. A pawn is an actor, but it has additional functionality, such as the capability of being possessed by a controller. A controller is a special type of actor class that allows you to take user input, such as a keyboard stroke or a mouse click, and use that to affect the pawn's movement. A character has its own character movement component, and this character movement component has functionality that's appropriate for a character. Things like jumping, swimming, flying, or whatever else characters typically do are characteristics of the character movement component. Now, the object, actor, pawn, character hierarchy is a little more complicated than it looks here. In fact, there are many different objects derived from each of these. These are just several examples, but there are many more. Another concept that you must understand is the difference between is-a and has-a relationships. Imagine you have a child class, and that child derives from some parent class. It's said that the child is a parent because the child derives from that parent class, and this is why the child contains all the functions and variables that the parent contains through inheritance. The parent, however, is not a child, so this relationship does not work both ways. Now, a child class can have its own child. Let's call it a grandchild class. In this case, we can say that the parent is not a child. The parent is also not a grandchild. However, we can say that the child is a parent, but the child is not a grandchild. The grandchild, we can say, is a child and also is a parent. It inherits functions and variables from both the child class and the parent class. Likewise, in the Unreal Engine class hierarchy, we can say that the object, being the parent of the actor, is actually not an actor, nor is it a pawn. But the actor, being a child of the object class, is an object. However, it is the parent of the pawn, and thus it is not a pawn. A pawn, being the child of an actor, which is also the child of an object, makes the pawn an object and an actor. Now let's discuss has-a relationships. Imagine you have a class, and because a class can have its own variables, some of those variables may be custom data types such as classes or structs. So inside of your class, you may have a member variable that is itself another class. We can call the first class the outer class, and the variable contained inside of the class can be called the inner class. Now, the inner class can have its own variables, some of which can be classes themselves. So inside of an inner class, you can have an inner class. In Unreal Engine, classes are nested within one another quite frequently. At the outer level of a game project, you have a class called Package. Inside of the package is nested another class, and this class is known as the World. Inside of the world class is nested yet another class, and this is known as the level. Now, objects that are placed in our level, these are classes that derive from actor or lower in the inheritance hierarchy. So a level contains actors. Now there is a type of subclass that is typically placed in actors, and these are derived from the actor class, and these are known as actor components. So it's said that a package has a world, and a world has a level. A level has actors, and actors can have components. Now, it's said that an actor component is a subobject of its owning actor, and the actor is a subobject of the level. The level is a subobject of the world, and the world is a subobject of the package. Now, there are some things that are not nested inside like all of these classes, and these tend to be things like assets such as meshes and textures. These are nested inside of the package itself. We don't refer to these as subobjects. So now you've had a refresher on the C++ programming language, as well as a bit of an overview of the Unreal Engine class hierarchy. This information will come in handy when creating games in Unreal Engine. Keep these concepts in mind as we develop our game in this course.